time to get hungry. Imagine that you're at a fast food restaurant kitchen at 12 p.m. in a weekday. What do you see besides food? Chaos. It's a high-speed frenzy where multiple chefs are actually working together to churn out meals as quickly as possible. Each chef has their own station, whether it's grilling burgers or preparing salads, and they have to pass ingredients back and forth without slowing down. And not just this, they also have their different kitchen tools to streamline the process, making sure everything runs as smooth as possible. And at the center, there is a supervisor. The supervisor is actually orchestrating the madness, ensuring that meals are prepared with speed and precision while keeping the quality top-notch. That's what we need to achieve with AI compute clusters. AI and machine learning compute clusters are high-speed performance systems specifically designed to handle large-scale computational requirements of AI and machine learning. These clusters consist of numerous compute nodes, each equipped with powerful GPUs, not CPUs, GPUs, to do what? To accelerate complex tasks such as model training and data processing. A cluster controller is there as well to manage and coordinate all the activities across those different nodes to optimize resource allocation and ensure seamless operation. Add to this storage arrays that need to be connected to the network using special network devices and technologies. This is where advanced networking technologies like InfiniBand and RoCE version 2 come into play, enabling high-speed, low-latency data transfer across the cluster nodes and leveraging what we call high-performance compute clusters, or HPC clusters. Now, I've heard a couple of weird names here, InfiniBand and RoCE version 2. What's that? What are these different technologies? Let's start with InfiniBand. InfiniBand is a high-speed networking technology that plays a crucial role in AI and machine learning compute clusters by providing ultra-low latency and high throughput between the nodes. This is the most crucial part, the speed, the bandwidth, the latency. InfiniBand is known for its efficiency in handling HPC environments, making it ideal specifically for AI and machine learning workloads where large amounts of data need to be processed and transferred between multiple GPUs and nodes in real time. This technology, InfiniBand, enables remote direct memory access, which is called RDMA operations, meaning that data can be transferred from one node's memory to another without going through the CPU. That's why I keep repeating, it's just the GPU, not the CPU. Without going through the CPU, thereby reducing the overhead. This ensures that large data sets can be quickly moved between different nodes, facilitating faster model training and data analysis in AI applications. However, with RDMA, networking requires specific and dedicated network infrastructure that are sometimes expensive. This is where RoCE version 2 is introduced. RoCE version 2. I mean, there was a previous version, and this is the second one. And the name itself is actually weird. What's that? Let me tell you that this is an acronym within an acronym. RoCE version 2 stands for RDMA, over Converged Ethernet version 2. Okay, well, what does it do? It's another essential networking technology that enhances communication between those GPUs across multiple compute nodes in a cluster for machine learning and AI using, wait for it, standard Ethernet. You are suffering because you were buying expensive network equipment while using RDMA technology? Well, you have your traditional switches. You have your traditional Ethernet switches that you can leverage while working with AI clusters because, hey, who wants to buy special equipment? Thank you, RoCE version 2. Okay. GPU on different nodes can now exchange data as quick and fast as possible using those different Ethernet switches, as I said. Rocky version 2 acts like a super fast conveyor belt that connects all the chefs. Ingredients are quickly transported from one station to another without any delays, making sure no one is waiting for what they need to keep cooking. The conveyor belt is so efficient that it actually skips unnecessary steps, like calling out orders or getting approvals from the head chef, letting the chefs focus entirely on their task. That's exactly what Rocky version 2 is here for. So where do we host those different AI clusters or AI applications in general? I mean, do I have to worry about doing it myself in my data center and then buy all the equipment and invest on, the data center and re-innovate everything? Or maybe there's another way. Yes, I'm here to tell you that there are multiple ways, actually. You can actually do this on premises by yourself, as you said. Or maybe you can take the help of a cloud service provider and host your AI applications in the cloud. Or maybe even do both. That's very possible. So let's talk about that. Hosting AI clusters on premises, that's the first example, is like building a fortress. Super secure and tightly controlled. Perfect for industries like finance and healthcare and government sectors with sensitive data. The bonus, super low latency, essential for real-time tasks like detecting threats or optimizing performance. Plus, it integrates smoothly with existing infrastructure. The downside? It's pricey. The initial hardware investment and ongoing maintenance costs are steep. And scaling up can feel like trying to expand a fortress overnight, costly and tough. The cloud is going to be your best friend. It's going to be your savior. The cloud is going to offer you easy scalability, letting you adjust resources based on traffic demand, and it saves you from maintaining a bunch of infrastructure. Centralized management is a breeze, making it great for complex networks. But there's a catch. Security risks in the cloud might pop up when sensitive data needs to be there in the open, in the cloud, and latency could be an issue sometimes for real-time tasks. Plus, you're at the mercy of your cloud provider's reliability and pricing. So what do? Well, combine the best of two worlds. The distributed setup. The distributed setup is the best of both the worlds at the very same time. Low latency for the edge computing and scalability of the cloud. It's ideal for real-time analytics while using the cloud for large-scale processing. Plus, with geographical redundancy, what do? If one part fails, the rest keeps going. Summary time. AI compute clusters are high-performance systems with GPUs for tasks like model training, managed by a cluster controller for resource optimization. Rocky version 2 is the technology that enables fast and low latency communication between the different GPUs across those nodes to improve the efficiency in AI workload using standard Ethernet devices. There are 3 types of deployment for your AI workload. You can deploy this in, on premises, where you're going to be guaranteed security and low latency. And this is ideal for sensitive data, but costly and hard to scale. Whereas cloud hosting gives you flexibility and scalability, but comes with potential security and latency risks. Combine both worlds, which is going to give you the distributed setup. And this is actually good for real-time analytics and large-scale processing. I hope that this has been informative. I'd like to thank you for viewing.